So how are we going to figure that out? How do you figure out what a particular animal should be eating? Well, first of all, it's very clear that animals that are designed to eat stuff that looks like this clearly have different issues from animals that are designed to eat things that look like these two antelope over here. Why? Because plants are anchored into the ground. They don't get up and run away. They also don't kick you or try to stab you with antlers. And they're generally rather docile. But they also tend to be spread out over a vast area. And depending on the climate patterns, they may be in season in one area, but then as the rains move, they become available in a different area. So if you're designed to eat plants, you've got to cover a lot of territory to find the food you eat. Now, animals, on the other hand, they aren't anchored in the ground. They tend to react negatively when you bite them. And so if you are a creature that is designed to eat other animals, you have to be capable of, number one, chasing them down, catching them, and then essentially killing them and dismembering them without becoming injured yourself and disabled yourself. And so how do animals do that? Well, we see that carnivores are optimized for predation. They are optimized for chasing animals down, bringing them down in an efficient fashion, killing them without becoming injured. Herbivores, on the other hand, are designed for foraging. That is, covering large amounts of territory at a low energy cost. And why am I bringing up the topic of energy? You see, the title of this slide is Metrics, Feeding Strategies and Energy Efficiency. It's because all animals must procure their food in an energy-efficient fashion. That sounds obvious, but think about it. Why is that important? Because if you expend more energy acquiring the food that you eat than you can extract from that food, what happens to you? I heard mumbling, but I didn't hear an answer. Excuse me. Let me make it clear. This is an interactive lecture. I expect audience responses when I ask a question, and if I don't get them, I'm going to start pointing out people, okay? So what happens if you expend more energy on the food that you can extract from the food once you get it? You have an energy deficiency and you starve to death. So that's not a viable strategy for survival. And for that reason, carnivores do not go out and look for the biggest, strongest animal on the savannah, because that's the animal that's likely to kill them or to injure them so severely that they will not be able to hunt. So instead, they look for weak, diseased, or animals that are defective in some way, that are stupid. Maybe they're wearing a MAGA hat. I don't know. Because those animals are easier to catch. And therefore, they will expend less energy catching those animals or they will be able to extract more energy from those animals than they had to expend catching them. Herbivores, by contrast, do not want the plant food that is dried out, brown, brittle, and essentially falling apart. Why? Because there's no nutritive value to those plants. Those plants have lost all of their nutrition. So instead, I'm sorry? Termites do survive on cellulose, but termites are insects, and we are focusing on mammals. And now, it's important because insects have completely different physiology from mammals. And because termites have specialized bacteria that allow them to process wood fiber and extract energy from that. But again, we don't have the physiology of termites, so that doesn't. and no mammal has the physiology of a termite, so we really can't look at termites as an example of what we should be eating. So, I beg your pardon? Termites look for wood. I mean, they look for cellulose. But again, ladies and gentlemen, if you guys want to debate the whys and wherefores of insects, we can do that after this lecture. This lecture is going to look at mammals because we are a mammal. So let's stay within the housing of this lecture because it's kind of silly to try and compare ourselves to insects. So herbivores, by contrast, seek the most lush, verdant, and newest, healthiest foliage because it is the most nutrient dense. Predation using, and this is key, I want you guys to think about this. Predation using an herbivore mentality is environmentally destructive. What do I mean by that? So carnivores look for, dead, dying, weak, diseased food. The herbivores look for the most fresh, lush, new, verdant food. So if you have that mindset of a plant eater and you want the biggest, the best, the prettiest, the most lush, and you go out and you prey on a species and you start taking out the biggest, most beautiful, most robust animals in that species, what are you going to do to it? You're going to drive those animals to extinction because you're removing the best genes from the gene pool. It's completely bass-backwards. The carnivores, on the other hand, are actually strengthening the gene pool because they're removing the defective genes. And this brings up what I call the beauty paradigm and species destruction. Species survival in nature is, again, as we already discussed, fundamentally a question of energy out versus energy in. You expend more energy than you can get from your food, you die. And so all true predators, again, seek what can be thought of as ugly food. They don't waste their time chasing healthy animals because they're not likely to catch those animals, or if they do, they're likely to be injured by them, and that means that they won't be able to hunt. So they look for sick, diseased, or very young animals, animals that are lame, or something that is already dead. And that means that they're weeding out the less fit genes, they're strengthening the gene pools. By contrast, again, the plant eaters look for the most lush, the most beautiful food because it is the most nutritious. And when we, because of our herbivore mindset, remove the best genes from animal species, we do what we have done historically, we drive animal species to extinction. And you contrast that with when you eat the healthiest and most lush plants, you swallow their seeds, you walk a couple miles down the road, you take a poop, and you deposit those seeds with some fertilizer, and you help spread those plants throughout the environment. It's a beautiful system when it works the way it's supposed to.